Good morning. Myself is Dada Savarikar, Assistant Professor and Head Department of Mathematics, Arts, Science and Commerce College, Mokhada, District Palghar. Dear friends, today we will discuss one important concept of mathematics. In particular, it is of TYBSC, and the subject is topology of metric space, and the concept is metric space. Now, before going to the actual concept of metric space, we will discuss 2-3 important concepts, just like absolute value function, triangle inequality of real numbers, and distance between 2 points. Now, by definition, we know that what is absolute value function. We know that absolute of any real number is itself if it is a non-negative, and it is negative of that number if it is a negative. This is the definition of absolute value function. Second, triangle inequality of real number. Take any three real x, y, z. Now, we know that distance between any two real number x and y, that is mod x minus y, is less than or equal to mod x minus z plus mod z minus y. Now, in this triangle equality occurs if and only if all these 3 points x, y, z are on the same line. Now, distance between any 2 points. We know that for any 2 point A having coordinate x1, y, and B having coordinate x2, y2 in xy plane, how to measure the distance between 2 points? By distance formula, it is given as follows: distance between x1, y1 and x2, y2 is nothing but it's equal to square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. Now, we will go for definition of metric space. Take any non-empty set x and define function d from x cross x to the interval close 0 open infinity, which satisfies following 4 properties. First property: distance between x and y is greater or equal to 0, that is non-negative property. Second, distance between x and y is equal to 0 if and only if x is equal to y. Third property: distance between x and y is equal to distance between y and x, that is symmetry. And last property is triangle inequality, that is for any three real number, for any three numbers x, y, and z in x, the distance between x and y is less than or equal to distance between x and z plus distance between z and y. If D satisfies all these 4 properties, then D is called as metric on X, and the order pair is called as metric space. Next, we will go for its examples. So, first example, very simple. Take x is equal to r and define function d from x cross x to interval close 0 open infinity as follows: distance between x and y is equal to mod x minus y for all x, y, and r. It is nothing but the absolute value function. Now, we check whether this function satisfies all properties of metric space or not. So, first, as it is absolute value function, the first property is obvious. Second, we know that modulus of any real number is 0 if and only if itself is 0. Third is very simple, and last is triangle inequality. But the triangle inequality here can be easily shown by using the triangle inequality of real numbers. So, it is easily shown. So, here function d satisfies all 4 properties of metric. Therefore, the order pair x, t is metric space. Similarly, second example and third example. Let us discuss second. Take x is equal to r and function d as d of xy is equal to 0 if x is equal to y, and d of xy is equal to 1 if x not equal to y. Again, this function d satisfies all 4 properties of metric space. First is non-negativity. Second, distance between x and y is 0 if and only both are equal. Third is symmetry, and last is triangle inequality. Therefore, this function d is also metric on set R. This is a special type of metric called as discrete metric. And last example, take any metric space xd is equal to rd. Here function d dash is defined as d dash of x and y is equal to d of xy upon 1 plus d of xy. Now, we have taken already one metric space, and on that metric space we are defining another metric d dash. Now, and we have to check whether it is a metric or not. But we know that as D is a metric on R, it can be easily show that first property, that is d of xy, d dash of xy is bigger or equal to 0. Second, third are simple. First triangle equality, as D itself is a metric on R, it can be easily shown that D dash also metric on R by using 1, 2, 3 and 4 properties. Thank you.